Hello everyone, let's wait a little bit until everyone joins us and then we'll start. Okay, let's start. Hello all, welcome to today's session, and today we are going to continue talking about inheritance, and basically we'll have two examples when we will cover the class composition and the examples where we can use instance of operator. That will be the first one, and then we will switch to the presentation about the interfaces and abstract classes. So that's about the agenda for today. Regarding your home tasks, thank you very much to those who managed to finish the activities, the activity 03, and also other activities were done by some of you. I checked yesterday, so those who sent the activities to me until yesterday, I checked them. Everything is fine for you. You have maximum points. Those who managed to finish them. yeah, until Wednesday I hope I will manage to go through the others. So currently I see there are 1, 2, 3, 5 of you submitted, correctly submitted the activity 03 exercise, and yeah, so waiting for others as well. Some of you are already submitted today, but I will check hopefully tomorrow, and then on Wednesday we'll just have a summary of everything we have. And yeah, this is what we have. Again, thank you very much those who managed to finish this exercise. Okay, let's go through. And right now we will have the example about the class composition. So remember, last time we created the hierarchy of the classes. So we had just the base class, let's say, the base class for all the persons in this hierarchy. Yeah, so this is the class person, and then we had several classes like employee, engineer, director, manager and director. And the hierarchy was that we have just the base class, because that's for sure that all these are persons, except data, of course, I mean all these. Yeah, then we know that we have the employees, and each employee is the person as well, so it means that all the objects you create using the employee class, you will also create persons. That's for sure. I mean, you know that all the employees are the persons, but not all the persons are employees. So please remember that we go from top to down, not the other way. If you say that the employee is person, that's correct. If you say that person is employee, that's again, that sometimes is correct, but not always is correct. That's why we cannot say it in general. And basically this is what the casting is about. Yeah. So again, as we talked about casting, please remember that if we go from right to left, then I mean, if we say that all the employees are persons, then this is the upcasting, and so we go this way. And we assign employee to person. So this will always work. Yeah, the casting on the top class, but we cannot always do the casting for the down class. So it means that we cannot say that we have the instance of person. Yeah, we know that we have the object person, and we cannot always assign it to employee, because not all the, again, as I said, not all the persons are employees. And from the programming perspective, if you assign person to employee and the person is not employee, then you have cast exception, and this is what we also have today. We will have today about the instance of operator. So in this case we have two classes, and to check if the person is employee, we can use instance of operator, but this is what we will have today. And just a small remark based on this example. So we have this class, yeah, employee, we extend person, then we go down to the hierarchy, and we have some rows here. We have engineer is an employee as well. Engineer is employee, then the secretary is employee as well. Then we have manager, who is also employee as well. And under the manager we can have another class, and that's the director class, which is manager. So, and please remember that in this case we go again up, and we can say that director is manager, and we can also say that director is employee, because again, please remember that we only, I can imagine that we go to right, so it means that director extends manager, manager extends manager extends employee, employee extends person. So in this case, we can say that director is manager, and director is employee, and director is person. So let's, if you understand this, it's really nice, and this may be quite important when you work with the objects in Java, because as I just said, you can always call, you can always assign the variables to up classes, to the classes which are located higher in the hierarchy. Alright, so we have these classes, and right now we can enhance this system. Let's imagine that that we have the bank. We have the bank. Let's say we have a bank, and so let's imagine that each bank has the director. In theory, we can also, let's imagine that we can extend such classes like corporation, or let's say so please remember that like in this case we don't have the classes, but such classes, but just if you think about what can be the super classes of the bank, then please note that the bank may be the subclass of the corporation. So we have the corporation, like again, Bank of America, that's called corporation, and basically the corporation, the company, or company, I can say this, or and company, it depends on the hierarchy. The bank is company, we know that, because that makes sense. But please remember that the bank is not the subclass of, let's say, if we have the banking system, but not the subclass of the banking system. So that's important to understand, because again, imagine that you have a banking system in the country, like in Latvia, let's say, or any other country. And in theory you may think that the bank is the subclass of the banking system, but that's not correct, because again, please remember that when we talk about the subclasses, we should also say that like any subclass is, we can name the subclass as the parent class. So again, as we have here, we can always say that the employee is person, the manager is the person, and manager is employee, and director is manager, and so on. The same we can say here. We can say that the bank is the company. It's okay. Maybe if we talk about the Bank of Government, then maybe say the Bank of Latvia. That's maybe not quite. We cannot say that it's a company, but it makes sense that we can name the bank as the company, because the bank should always have the managers and the employees, and so in this case we can always say that the bank is company. So we can say the bank is company, we can say the bank is corporation, we can just but we can not say that the bank is banking system. It doesn't make sense. Because please remember that we can say that we can't say that bank is banking system. Banking system. It doesn't make sense. That bank is banking system. It doesn't sound. It doesn't sound proper. Hope you agree. So that's why we do not say this, and this is what the inheritance is about. Please remember that we should always say that for the parent classes that the object we inherit the object which comes from the superclass, we should also say that it is a superclass as well. So right, and here we can create some attributes. We can say that we have the name of the bank. So we can create the constructor. So maybe we can skip the constructor. We can just create getter and setter again. That depends on the scenario you have. Like if you have something which should be initialized at the beginning, then you need to create the constructor. Okay, maybe in this case that makes sense if we initialize it. It's not so important in our case, but again, that's up to the scenario. When there is such need, like you cannot create the object without some mandatory attributes, then you can create the constructor with all these attributes. Otherwise, you can skip passing these attributes in constructor and then just use getters and setters, or in addition you can create both options. That would be this way. So in this case you'll have two constructors. It means that you'll have two options to create the objects. You can create the objects with name or without name, and then set name after that, or you can basically, that's up to you. Up to the scenario you have. In our case, we don't have such necessity and such critical restrictions, but that makes sense if we have if we don't have the bank without the name. In this case, we have only such constructor. Alright, so now we have the bank, and we can use the classes we created before. So let's say that we have only one director of the class, of the bank. So that would be director, and here we have director of the bank. So here we have the director of the bank, and we can set director. We can set director. We can also say that we can. That would be interesting. We can fire director, set director, or we can fire director. Fire director, so it means that we will set up director to that. And we can also get director to know who is the director of the bank. So here we have one class inside another. So we use this director to place it here. So usually we have such classes. Like in this case, you can see that the director is mostly used for the structure. Like we have some data about director, also the data which comes from the superclasses, like the name, surname, date of birth, and so on. So in this case, director is used as the object. Yeah, of course, director is used as the object, which mostly stores the data. Stores the data, and in Java we use the classes, we use the objects to actually store the data and transfer the data. Like that would be, as I mentioned, you can say we have the files, then we can have the file data, that would be the content of the file, like string content, that can be the file extension. We have date of change, date of creation of the file, all the information you can collect about the files. Yeah, so we can store them as the objects. So in this case, maybe we won't have any actions to be done with the file, specific actions. Yeah, like we can. It's mostly can be used to store the data and transfer the data. Yeah, so in this case, please consider that such way that we can use the objects to store the data and basically to not do any actions. Not any specific actions inside these classes. Just like that would be the attributes and getters and setters there. Yeah, that will be about it. So here we have such attribute. Then we can also have the list of all the employees to import it. Then have the list of employees. Yeah. And here we will have the employees. We can directly create them. And I list of them. Employee, of course, without. So here we can have the getter. Here we can have the getter. We don't need setter again, please remember, because I said it once, but just to remind you, for collections we don't normally need the setters because the collections are objects. Because the collections are objects, and we normally just add or remove the elements from them. You don't need to actually change the objects, but the setters are used to actually change the object. Change, replace the object. But yeah, for collections it's not needed. Please remember that. And that's why I use getter here use getter only. Alright, so this is done. Yeah, we have employees, we have director. So yeah, this is, I think, for the bank. That would be fine. We have director, and then for the director, let's say one small example, and then we'll go to the next examples. So here under director we can the same way we can add the list of that would be the list of subordinates of the director. So that would be the list, and these would be employees, and here we'll have subordinates. Employees. So then I will create the collection. Here we can add subordinates. I'll just create getter. We can use this collection. So we'll link the employees subordinates of director to director as the object. And maybe the last thing what we can add is the, let's say, the boss. So we can add the boss, and the boss may be the manager. For employee, or we can just call it manager, or no, let's say boss. The boss, yeah, you can say that we can add the boss as the manager. So in case employee is the manager, then this can be null. So if employee is the manager, boss should be null. We can do it. This one. Okay, and right here I will create getter, and I can also create the setter for the boss. Right, so here we just create the linkage between them, the composition. Okay. Okay, so this one is done. Yeah. So please remember that we can basically have this linkage in both ways. Like for each employee, we can assign a boss if needed, and for the maybe let's say not for the director but for the manager. Yeah, that would be more correct. Yeah, sorry, not for director but for the manager. That would be more correct. And that would be cat subordinate. Yeah, so yeah, this will be correct. Because yeah, in this case we can have the subordinates for the director, and the same we can also have the subordinates for the manager. Right. So that would be correct. Okay, so here we come through these, and right now we can check one example of using the instance of operator. So let's imagine we have let's say 3 classes. So the first class would be sweet. Let's say candy. I'm not so familiar with candies. Well, maybe let me think. Yeah, maybe let it be candies. Candy. Or no, let's do candy. No, let's just candy. Okay, so I have the candy, and that would be the, let's say, candy object Java. Maybe I will just search for some maybe properties for a moment. So that would be yeah, okay, maybe let's have the candy, the name of candy, and what else we can add, and maybe let's have the number of calories. We can also add grams of sugar. Why not? And so I think that should be fine. So we can add setters and getters of these attributes. So and I think that should be fine. So yeah, and now we can create another class that would be toys. the toy class, and we can give name to it, string name. Then we can each toy may have the category. Maybe weight as well. Yeah. So here we may use getters and setters. Yeah. So something like this. And maybe let's create a little bit more classes just to so that would be class teddy bear. And we can extend the class because we know that teddy bear is toy. And let's say we can I'm not sure if teddy bear has the default weight. Let me think. You see, okay, maybe there's no name. Okay, we can skip defaulting weight, but we can default the name of the bear because we know that his name is Teddy. Right, so we can maybe we can do it this way. So we'll have the constructor, and maybe one more thing I forgot to do is to change the name to protected. Here we'll need to use the name protected because I want to access the attribute, I want to access the attribute, let's say one moment, I think just maybe small check. Oh no, we cannot, yeah, for protected we cannot, for private we cannot, so yeah, I'll use protected. We will need to access the name inside the constructor of teddy bear class, and that's why I define it as protected. So it means that once the teddy bear is created, I can assign the name of teddy bear, and his name is Teddy. Right. Okay. So that's for teddy bear. Maybe can we create some subclasses of candies? Moment. Yeah, okay, maybe let's do it. I'm not so familiar with the... Okay, we have some types of candies, and that would be... okay, we can use candy this one, and then this would be, say, Skittles. So here we can default as well the name. Maybe no, let's maybe use not candy but candies for that would make more sense. Candies as the class. So if we create subclass, I think for candies that makes more sense. Okay, let's change the name. Okay, so this is time for candies, and again I will use protected to change the name for Skittles. Sorry, okay, right, so here we have Skittles, and I will default the name to Skittles. So that will be this name. Oh yeah, of course, I need to extend, sorry. The candies. And yeah, here I will default the name for candies and the name of Skittles. Alright, so here I have two classes and then maybe just to, yeah, maybe I will add more. So I will Snickers, so here I'll do the same way. I will default the name. Of course I need to extend the candies. The name, and then the Snickers. Okay. And maybe just to make it more clear, let's create maybe another class, and then we'll go to the direct usage of instance of. So that would be say, you know, for candies we can add one more thing. We can add the flavor. So here we'll have and here we have flavor, and again I will not protected. Here we'll add the flavor and out. I can use getter, and I'll use setter as well here. Right, so here we will do it, and for Skittles we won't have the default flavor, but I will, let's say I'll put another class, and that would be fruit Skittles, or no, fruit Skittles. Fruit Skittles. And we can extend the class of Skittles. And here we will default the flavor. And I'll say our flavor is fruity. Just a small example, and basically what we have here, we have two classes, class of candies, then we have the class of toys, one toy, and here we'll have the subclass of toy, that's teddy bear, the default name, just to extend it a little bit with some functionality. Then we have the candies, and then we have Skittles and Snickers as just a subclass. And yeah, the subclass of Skittles would be fruit Skittles with the flavor free. Alright, so we have all these classes, and let's have a short example of how can we use instance of operators. So that's an example. Instance of. Yeah, okay, let's do it. And here we may have several options. Yeah, maybe let's add it from console. Just remember that we can use scanner plus, so we can type from console. Maybe let's do it. Or yeah, I think we can do it. So, moment, I will quickly copy the this scanner definition. Just a moment. Yeah, so that was it. So here we can create the scanner, and so I will call scanner at the end. And let's imagine that we have right here we can use static. Static attributes will have two boxes, let's say. So we have that the first one would be the list, the second one would be the list as well, but we will have two different boxes. And so this would be box of candies. List. And here I will create box of toys. Yep, here I'll do it. And here we can make box of toys. And so here we have two different collections. And yeah, firstly I will ask user to pass the number of how many items do you want to let's say to the boxes. And here we'll have the input, so that will be number of items. And here I will read from scanner, so that will be next string. Yeah, I'll use next string, just to make it easier, and I will parse it into integer. Right, so here we have them, and here we'll just go through, we'll have the loop, and we'll repeat the entering of the elements to the list. So that will be this way, and here I will increment the I, and yeah, here we will enter the elements. So first of all, we'll enter yeah, first I will ask user what you would like to enter. That will be what item do you want to enter? Yeah, and here I will have three types of items. So first I will ask user to enter the item, so that would be item, and I will read it from user input. And so here I will create the method which will return me, which will create me the object. So here we have different classes, candy simply, so I will need to do it this way. So that will be get object. So that will be get object and get item object, and that will be more correct. Get item object, and here I'll pass the item name. I'll pass it from here, and here we'll have basically we can go through all these choices. In theory that can be done dynamically as well, but we will not make it so complicated. We'll just use the switch and here we'll switch by item name. And let's say we have different options here. So the first one would be the teddy bear. In this case, we can return new the new teddy bear. If we don't need break because we have return, so that will automatically break the wall method and just go out. So if we have teddy bear, then we create teddy bear. If we have simple Skittles, we will return Skittles. Let's say not without the column here. If we have brewing Skittles, we can create them. Brewing Skittles, and what else do we have? Maybe we can have the mix of candies, why not? So that will be a mix of candies. It's a candies mix. So that will be candies class, yeah? The candies class, in theory, yeah, I think that should be fine right now. And by default, yeah, please remember that we need to return something. We can return null if something is wrong. So that will be again our spell step, which is to not create object. So what we'll have here, we have item name, and we can put the item name there. So here I will use the object type, and I can use item object, and that would be, I'll get it from the method. So I'll use get item object and I'll write item name. And here I can use instance of, yeah, because directly I cannot do it. Like if you type box of candies, I pass item object, this won't be acceptable because we can see that not correct, because compiler is not known, and actually we also don't know what is the input by user. I don't know what's the type of object. Here. So what we need to do, we can check. Basically, we have two collections, so we can easily check if item object is instance of candies, so we can add it to collection of candies, the box of candies. So that will be item object. In this case that will also not be correct, but what we can do, since we have a check of candies, yeah, unfortunately compiler does not understand that we have the check here. We do know, compiler does not know, but in fact, yeah, we have the check here, and that's why we can be sure that here we will have the object which is the subclass of candies. So yeah, here we'll have the compiler does not understand that the object is the subclass of candies class, but we can be sure, we are sure because of the check we have above. Right, so yeah, fortunately compiler does not see that we have a check here, but after this check we can be sure that item object is the class belongs to the class or the subclass or any subclass of candies class. Yeah, so else if we can add this is that if item object is instance of what we have toy, if this is toy, then we can add the object to the box of toys. Then we can add we must do the casting. And we are sure that this will not trigger the class cost exception, because again we have this check. If we skip this check, we will have, that's most likely, that we will have class cost exception, because in this case that would, if we create, let's say, toy instead of candies, then this will try to cast toy to candies. That won't be correct, and this will trigger class cost exception. So yeah, here we have else if, and otherwise we can just say that such item cannot be added. So it means that it's none of toys or candies, then we cannot add it to the collection. Alright, then after the loop is done, let's say we can print out how many items each box has. So that will be the box of candies has. So that would be candy, a box of candies, size. items, and the second would be the box of toys has, so here we have box of toys, and here we have the size items. Right, okay, and I think right now we can test it. So I will run the program. Let's say I want to add 8 items. So I would like to enter add. Okay, I will enter, let's say, teddy bear. Okay, for some reason teddy bear cannot be added. That's interesting. Why this? Here we have the first issue. That's interesting. Teddy bear, and this should return as teddy bear, which is the subclass of toy. Yeah, that should work. Okay, let's try again. Oh, maybe I added additional space. We need to debug then. Then we need to debug and see what's the issue here. Okay, so I will debug it, and then we can check what's the issue again. I will try to add, let's say, 8 items. I'd like to enter teddy bear. Teddy bear, and I want to switch to a different screen. So currently we are here, and we can see that I think that the object will not be created. Yeah, it's not created. Okay, I got it. I think I got it. Sorry, not next, but next line. Here's the issue, because that's just not the first element. Okay, and please remember to use next line. I think in this case we better also read line, because actually we want to go line by line, and that's why we want to use next, but we'll use next line. That's easier to use. Okay, that's this way, and we can run it again. So then I write 8 items, and let's say I want to add teddy bear. Then I would like to enter a mix of candies. Then I would like to enter Skittles. Let's say I want to add Skittles as well. Then let's imagine I want to add something which is not correct. Yeah. Then I'll add another teddy bear. And more mix of candies. And Skittles. And yeah, so here you can see that we have 2 toys added and 5 candies. Yeah, so here we have instance of. Basically the idea is that right here we have the input, and the program does not know what kind of input do we have here, because it may trigger the creation of one of these objects. That can be the subclass of toy class, or that can also be the subclass of candies class, or that can be new as well. So we have 3 possible options here, and so since the classes are not related with each other, we can use object, because remember that object has a superclass of all the classes, so we can upcast every object to object class. This will be correct, and we can use it to transfer our objects. In this case, that would be that we transfer one of these objects there. And then we use instance of to check to which class this object belongs, and then based on what we have we can add it to corresponding collection. Since unfortunately compiler does not understand that we have the corresponding check here, we must do the casting, down casting here, but that we can be sure that this will not trigger any exception again because we use instance of operator. Otherwise, if we don't use it, we may have class cast exception, and so then we can use try catch to handle such possible issues. Right, if you have any questions you can prepare them about the instance of operator. Right now let's have 10 minutes break. We'll be back after 10 minutes. Okay. Alright, let's move on. So yeah, this is what we have with instance of. This is the idea of how to check what kind of instance do we have. And as I remember, let's quickly check. Let's quickly check. I think that was activity 04, I guess. Or a moment. Yeah, I think that was activity 04 when you have to use, when you need to use the. So we have wrote. Or not. Be sure, I'm not remember which activity was it when you had to use this instance of. I think not this one. Okay, not sure which one was it, but okay, that's definitely activity 06. When you have to check this, because I remember there was also something like this in activity of, okay, I don't remember, but you will have you'll need to use instance of in your home tasks. So yeah, you can check the approach we used here. This can be applied for all the different types. Yeah, in this case we used object as the base type, but that can also be any, let's say, superclass, and then we can assign subclasses to it, and then we can check 2 or more different subclasses, and then it will split them in different cases. Alright, so this is it about it. A moment, I will quickly check if I haven't missed anything. And so quickly check. Inheritance. Yeah, I think that's fine. Okay, so this is done, and now we can move to the presentation. And the presentation is related to abstract classes and interfaces. So previously we talked about in the previous course we cover most of the topics. Here we have some additional, more deeper analysis of these, but in this course we had the interface or inheritance when we actually use the superclasses. So this concept stays here. So we talked about classes, just the objects, and then we also talked about the inheritance, when we can have the superclasses and the subclasses. So this topic is, I would say, this is the extension of the topic about inheritance. That means that mostly that's the extension for the inheritance, because normally we used abstract classes and interfaces as the superclasses for other classes. Superclasses were, let's say, interfaces. We can also say super interface. Yeah, it's the parent. Yeah, parent of the classes, which can be used inside the classes. Yeah. So for this concept, this is related to inheritance. There is one exception for the abstract classes. We'll talk a little bit later, but yeah, for abstract classes, maybe if we go a little bit ahead. Abstract classes can be used as a separate classes if we have the static methods only. So in case we have only static methods, then we can use the abstract classes without any inheritance. But that's maybe a different topic here, not different topic, but a bit to go a little bit ahead, maybe just short introduction. So here we talk about we'll have 4 topics: keyword final, abstract classes, interfaces, and nested classes. We have not talked about the nested classes in previous course, but we'll cover them in this course. We'll also see some examples about them, and yeah, let's start with keyword final. So previously, as you remember, we used the keyword final to define the constants. The constants, partially, the constants, because as you remember, final can be used basically not for the, let's say in Java we don't have the constants as the constants. That would be in other languages, like you define the variable, not the variable, you define the, actually that's a little bit crazy because we can't actually call the variable, the constant as the variable, because variable by the name means that it can change its value. For the constant, we cannot really change the value, but I hope you understand what do I mean. So for the constants in other languages, that's normal is that we define the we define the variable, we define the value for the variable, and never ever just do any manipulation with it. In Java we have one let's say additional feature for so-called final variables. This feature is that by default we can skip initializing the variable, but we should we can initialize it, let's say in the constructor, and then we can do it only once. It means that the variable and the value can be assigned only once, and after that we cannot change it. This is for the variables, so it's pretty much clear. But what we can also do, we can use keyword final for classes, for methods, and as I mentioned, also for the variables. So for the class, it means that the class cannot be extended. So it means that you create a final class and you cannot create any subclasses from this class, so you cannot extend it. For the method, that means that it also is applied for the inheritance. So it means that you have public or protected method, and it means that you cannot override it in the subclasses. Like just the method, you can use it, but you cannot override it. And about the variable, that's pretty straightforward. And value to find a variable can be assigned only once. It can be after declaration, and it's called blank final variable. Value of final instance variable should be assigned in each constructor. Like if you create the final variable, then you cannot just assign the value in any method but constructor. So it must mandatory be done in constructor, because it actually means that once the object is created, you must have the value assigned to this attribute. Local initialized final variable should be initialized before it is used. That's not for the class variable, but for the variable defined in the methods. This is how the constants looks like. You already know. Just use the keyword final and before the type, and then we'll have the final variable. Please remember to use the correct naming for the variables, for the constants. As you remember, for the variables we use so-called camel case. Means that the variable must start with lowercase letter, and then we separate different names names inside the variable name using camel case. And so we have uppercase letters for the constants. Please remember that all the letters should be in uppercase normally. And then we separate each word using underscore. And that's what we have in Java. And as an example, we can also have an initialized. But yeah, since this is the instance variable, then instance constant, then it means that we should assign it in the constructor. And it makes sense. We can usually do it for, let's say, for the identification number of persons. Like it means that we create the object of the person, then we assign the identification number for the person, and then it will never be changed after that. Makes sense? So in such cases we can do it. Yeah, and when we do it for the objects, it means that it actually means that we can actually change the content of the object, but not the object itself. So please remember that the objects are stored as the references. So if we assign it to the global variable, so this will be stored as the variable, means that the reference will be stored there, and you cannot replace it with other reference, but you can actually change the content stored under the reference. Like in this case, that would be for the list we had here. So for the list we can also define it as final. This will be correct as well, because we will not replace these objects. And then we can check that this will work the same way. And there's wait, yeah, of course, sorry. Without the quotation marks. No. So yeah, this will work the same way. Actually, again, we can change the content of the array list, but we cannot replace the reference. But this is not what we usually want to do, and that's why the approach of using final would be correct here as well. But yeah, please remember that if we have the private attributes and we create our classes and we don't change the reference of the list, then in fact final is not quite needed, because actually this is our class we control. But maybe sometimes that's also fine if we define such variables as final, but yeah, normally we use it for constants. Okay, so here it's done, and we can go to the next slide. Yeah, there are some properties of final objects. Yeah, this is basically what I said before. In primitive types, final objects not. In different primitive types, final objects are not immutable. Because again, as I said, the objects store the reference, but not the content of the reference. So that would be that it points to the same place, and the same the place of the to which this variable points us will be the same, but the content there will be different. Yeah, so this will still be modifiable, and we can do some actions with it. Right, so this is about keyword final. So yeah, nothing more to say, but please remember that we have such properties. The final class cannot be extended, final method cannot be overridden, final variable cannot be reinitialized, and yeah, this is what we have. Then in object-oriented programming we have such additional feature called abstraction. By definition, it means that this is the process of hiding the implementation details and showing common functionality to the user. Yeah, as I said previously, in object-oriented programming we have such, especially when we talk about abstraction, when we talk about the encapsulation, the idea for us is to provide programmers to make work for them as comfortable as it can be. So, as I said, we don't care how the program works. If it works, then just keep it working. And we, as programmers, when we try to build something, we usually use what is already created. Again, as I said, when we work with frameworks, when we work with the software, if we add some more features to the software, then we usually use the existing classes, the existing implementation, and so that would be like add something, change something, create something, and so on. Again, if you work maybe, let's say, with the e-commerce website, so then that would be, you have the list of products there, then you may have such classes like create product, add product, change product, create reference product, link products, and so many such things. And like in theory, again, we have such program already created, we have such software, such functionality, and actually the thing is that to be honest, I don't really care how it usually, I don't care how it works. In theory, if I have time, if I have such wish, I can check how it works, but this is not what I really need, because I want to take time, let's say. I don't really need to go through everything there. My job is just to use all these things, to apply all these things, and create my own solution, because these things are provided by somewhere else. These things are already tested. So let's say there can be certified, so we definitely know that these things work. And in case something does not work, it means that this is our issue, not the issue of the classes. Let's say it can be the classes we use. And so in this case, the abstraction also points us that if something does not work, then the issue is somewhere on our side, not on the objects created before us. This is one of the points of abstraction. The idea is that we do not see directly what is located, what's hidden under the logic. And of course, since the abstract classes are the classes, then if the actual objects created from the using the abstract classes are the subclasses of the abstract classes. And they let us focus on what the object does instead of how it does. They're pretty much straightforward. Like, let's say if we have the class of files, then we can just focus on what files we do, not just the exact file. Also, they point us to such thing like all the abstract classes. If you have the object which is typed as the abstract class, if we have the variable, sorry, not the object, but the variable which is typed as the abstract class, that we can be sure that the type of the object is not the class we have. It's not the type in the class it is defined for, because we cannot create the objects from the abstract class directly, but we can do it from the subclasses. And so in here we can also point, it's not set here, but we can point that the actual type we are working with is extended from the abstract class. So it cannot be the independent, let's say, independent object. That should be the independent. It should be independent from the abstract class. So our abstract class, and we have subclasses, and then we can point that this class this object will be typed as one of the subclasses of the abstract class. And yeah, so when we talk about abstraction in general, in Java we have two ways of abstractions. We'll talk about both of them, and these can be abstract classes and interfaces. For abstract class, we can also define let's say, the percentage of the abstraction for abstract classes and interfaces, and for abstract classes we can abstract them from 0 to 100%. Actually, that's not so true about 0%, because I would say 0.1% or something like that, because we cannot actually escape the abstraction in general for the objects. I mean, as I previously said, if we use the abstract classes as the static, only using only with the static attributes and methods, then this can be the abstraction is 0%, but for the objects, yeah, we cannot achieve abstraction of 0%. For the interfaces, yeah, that's correct, because the interfaces are not part of class hierarchy. This is the addition to the class hierarchy. That's why the abstraction will be 100% here. Alright, and yeah, the first way to achieve the abstraction is to use the abstract classes. So as it states from the class name, abstract classes are the classes, and the only difference in the definition is that we add the keyword abstract to it, and it's known as abstract class. So this is about the definition. The only difference on the definition is that is defining its abstract class. But regarding the functionality, there are some differences. The first one is that it can have abstract classes and non-abstract classes. So non-abstract classes, methods, abstract methods and non-abstract methods. Non-abstract methods, these are just simple methods, the same kind of methods we use for simple classes, and the abstract methods are the methods which have no implementation there. So this is basically the key difference. What we have in the definition of the abstract classes means that these classes have no implementation set. And when we talk about the implementation, it means that this is what is located under the curly brackets. So this is called from here to here, and this is called the implementation of the method. So this is called implementation of the method, and it actually means that for the abstract classes there can be such methods. They must be instance methods. They cannot really be static. They cannot be static methods. Normally, quickly check. and that should not be such case. No, there should not be such case. Public abstract class. Yeah. Yeah. Not fair. Yeah, of course that cannot be possible. Yeah, fair one. Yeah, we cannot public. Of course, we can't do it. We cannot do it because that's it doesn't make sense. Definitely. I just checked if nothing has changed in the last versions of Java, but yeah, that's for sure. It's not correct and it makes sense that you cannot define static methods as abstract methods because again, static methods belong to the class, not to the hierarchy of classes. So it means that they cannot be changed. So we cannot override them. Okay, and it needs to be extended, and method must be implemented. Abstract classes can extend other abstract classes, and in this case the method should not be implemented. But if we go like we have hierarchy of abstract classes, we have the first abstract class which extends, and then which is inherited in another class, and so on and so on. Then once we reach the class which is not abstract, then in this non-abstract class we must implement all the methods of the abstract classes. All the abstract methods of the abstract classes. Please remember that abstract methods can only be public or protected, because the definition of the private methods as abstract methods make no sense, because you can for the abstract methods, the idea is that we must implement them in the subclasses, and we cannot implement private methods in the subclasses, right? We cannot override them. That's why it doesn't make sense to create them, to be able to create them as abstract methods. But for protected and public, that makes sense. We can do it because we can actually implement them in subclasses. And the last thing is the abstract classes cannot be instantiated because they are abstract classes. That basically comes from the name, so that we have some kind of abstraction here. This may point us that we cannot create the objects from them, but the main point is again related to the abstract methods, because if we again, as I said, there are two main usages of abstract classes. The first usage is that again, we want to achieve the abstraction, that's for sure, and we use them as the superclasses, and then we implement the abstract methods in the subclasses, right? That's the first usage. We can do it this way. The second usage is and in this case we cannot, that makes sense, we cannot instantiate because we have some abstract methods, the methods without the implementation. But please remember, if the methods are public, then in fact, so let's imagine you have instantiated the abstract class, then you have some public abstract methods. That means that you can call them from somewhere else, and basically let's imagine what happens when you try to call these methods. You actually want to call the method without the implementation, which doesn't really make sense. That's why we cannot do it this way. It means that we cannot create the objects from the abstract classes. That's one thing. And again, another option is to use the abstract classes only with the static methods and static attributes. And in this case, since everything is static, there is also no need to instantiate such objects, and that's why for the abstract classes we can say that they cannot be instantiated, so I cannot create them objects from them. Then abstract class must be declared with an abstract keyword, and that's what I said. It can have abstract and non-abstract methods. That's for sure. It can be instantiated. Let's duplicate entry here. Change it. That's the duplicate entry. It can have constructors and static methods also. Yeah, that makes sense, because constructors, that's the part of any class. So in this case, this property comes to the abstract classes as well. You can have final methods, which will force the subclass not to change the body of the method. That's the same as we have for all the classes, not just only abstract classes, but for any class in Java. And as an example, that would be that we have the shipping class. Then inside the shipping class you have the reports object. Then there can be another object, field need report, which will use company. Then shipping main will also use company. Then we'll have domain, which has the company, which has the fleet. That can be the vehicle, and vehicles can be truck or river beach. So in this case, we may have when we talk about company, in this case we have actually nothing to link it to. That's why that's the normal class. But when we talk about vehicle, we can see that vehicle can be truck or river. So vehicle itself cannot really be the class. So normally when we talk about such things like vehicle, then we cannot really say that vehicle is separate. It can be the object. We cannot instantiate vehicle because we must know the type of the vehicle. And in this case, that would be that the vehicle still remains the superclass of, let's say, truck or river beach. That can also be just a simple car. Yeah, but for the vehicle, we must, to create the object vehicle, we must know the type of the vehicle we want to create. So in this case, we cannot have vehicle as a separate object, but only as the superclass for such classes like truck or river beach or car, bus, or something like that. So car, bus can be the objects, but vehicle itself cannot really be the objects in such scenarios. That's what we have here. Vehicle. Then again, we can use the vehicle as the same way as we can use the superclasses. So we have the attributes, which can then be used in the subclasses as well. And of course, as for each subclass, we can add additional attributes as well. So here's the way how it can define the class. So here we have the methods. So these are not the attributes, but the methods. So these methods help you to calculate let's say fuel efficiency or trip distance and trip distance. And here we define them as abstract because we have not the standard implementation for all the vehicles. Like in this case, if we don't use the abstract classes, that would be like we skip using abstract class and abstract methods, and here we just leave empty implementation. So that would be this way, and of course that doesn't look pretty, doesn't look correct if we just simply keep the implementation empty. So yeah, I think that makes sense. So if you have the method without the implementation, then someone may ask you why do you actually need such empty method. It doesn't look well, it in general doesn't make sense. So yeah, that may also be the point if somewhere you have such situation when you have the method and you understand that you can only implement this method in subclasses, then in this case you may think about using the abstract classes. Actually, yeah, in my experience, that was, that was the first time I used the abstract classes in my practical job. Actually, I find there was the method. Yeah, that's what I just said. There was one method inside which there was no logic, and that was the point. We need to use the abstract classes, so I used the abstract classes there. And this may be the pointer to you. But yeah, in this case you can see that there's no implementation, default implementation for them. So what does it mean? It means that you define this class as abstract, you define abstract methods there, and you implement these methods in the subclass, and you will have the implementation there. So yeah, you can implement, and you can also extend them using additional methods and attributes if you want. That is allowed. So basically the same way as for all the subclasses. Okay, yeah, this is it about abstract classes. So again, the idea is that these are just the simple classes with let's say two additional properties that they cannot be instantiated, and they can have abstract methods without implementation. Right, the next topic is interfaces. That is the thing which is related to inheritance as well in Java, but it works differently than the classes, and it has let's say a little bit different construction and different meaning. Basically, what do we have? Interface is a shared boundary between two separate components of computer system exchanging information. That's maybe, let's say, more overall definition of interfaces, but yeah, if we go maybe a little bit more close to the programming, that would be that we can explain and define interfaces as the contract between user classes and user class and use class which implements use interface. So that would be the thing which is shared between the classes. So comparing to the abstract classes and to the simple classes, we can use them as the parent classes, the super classes, and the abstract classes. The interfaces, so yeah, we cannot really say that we actually share the classes in between the classes. But the interfaces are the things that, in fact, they can also work partially as the as the superclasses, and not as the superclasses, but kind of superclasses and the classes. Yeah, we can easily say that we share the interfaces between the classes. And yeah, we can say that Java interface is abstract class, which with declaration of methods without actual implementation. Yeah, in fact, we can say it. So in theory, yes, that in some way we can say that the interfaces are the abstract classes, but yeah, I don't really like to say that the interfaces are the classes. But yeah, the properties are kind of similar to them, to the classes. Yeah, that's the Java mechanism to achieve abstraction. One of the mechanisms, as we already discussed, there can be only one abstract method in interface, but yeah, there can be only abstract methods, but not method body normally. Actually, we'll have such thing that from Java 8 there are default voids, but yeah, this is. I think we will have some examples using them, and in this case, maybe this point will not really be correct, but we'll have examples on this. And again, the idea is to achieve the abstraction and to achieve such thing I mentioned called multiple inheritance, which was achieved in C++, but in Java we cannot achieve it without the interfaces, because, as I said, in Java we cannot extend multiple classes compared to C++, but we can use multiple interfaces there. So yeah, it's used to achieve abstraction. By interface we can support the functionality of multiple inheritance, and it can be used to achieve loose coupling. Yeah, this is what I mentioned before when we talk about coupling. So in this case, we don't really need to closely closely link the classes. In this case, using the interfaces, we can let's say create the pointers to the group of classes, but to not link the pointers and the markers. Yeah, the markers, and assign the properties to the group of classes, but to not create the inheritance of them. Right. So, and the properties are that the interface can be declared by only public access modifier. In Java interface lists method declaration without actual implementation, but there can be default implementation. We'll see it. Yeah, interface variables are implicitly public static final. So it means that for the interfaces we cannot create the variables, the attributes, only constants, static constants. And yeah, one interface can be implemented by several classes. Classes can be inherently unrelated. So it means that we have two classes. The classes are not related with each other using the inheritance, but both of them we can add as many interfaces as we want, so some of them can be the same. Yeah, one class can implement several interfaces, and from here we come to multiple inheritance. So we define the interface using the public interface, then the name. Yeah, we can use extends. It means that it will extend the it will extend other interface, and yeah, then we can declare the members of the interface. So that will be this way. We will have the interface flyer, so kind of the same as we have for the abstract classes. So we have the name, and let's say the parent. For other classes, in this case, it can also be the parent for the other interfaces. And yeah, here we have the interface flyer, and then we have some voids, take off, land, fly, and then we may have the class airplane, which will implement the interface flyer. Then we must implement these interfaces the same way as we do for the abstract classes. Yeah. So we need to implement these interfaces and build some logic here. And in this case, we do not have so much restrictions as we have for the super classes. Like in this case, if we want, we can extend any class we want. We can also implement other interfaces here, multiple interfaces. So let's say it can be more flexible. But the thing which is not so flexible is that we cannot create the attributes for the interfaces in Java. In different languages where object-oriented programming is used and where the interfaces are used, there is such possibility, such option to create the attributes which are not constants in interfaces. But in Java, unfortunately, there is no such option. We can only create the constants there. So yeah, and this would be the example. We'll have the interface flyer. We have the class animal, and what we can see here, airplane can extend the class vehicle, so that will be the super class. Again, please remember that only one super class can be extended for each class. And then we can have two classes which will implement interface flyer. So that means that they should have all these methods here implemented, both of them. And yeah, the same for the Superman. Also should implement these methods from the interface flyer, but again, they're not related with each other using them super classes. But for each of these classes, we point that each of these classes must implement these three methods. So in theory, we can use the interface and then call these methods for each of these classes, each of these objects. Yeah, Superman extends. Superman extends the class Homo sapiens, I guess it's mentioned here. And then bird extends the class animal. Homo sapiens also extend the class animal and extends class animal. And then we can have such hierarchy of the classes and one interface. So this can be done here as well. And then please remember that we can have such thing called virtual methods. And the methods declared in interfaces are actually virtual methods because their behavior can be implemented differently in implemented classes. So it means that we can declare the variable as person, like in this case that will be, and the person will have the method work. But since you use this variable person, so that you can call the method work, but directly just by see that you have this variable and you call this method, the implementation will the implementation depends on what is the object assigned to this implementation. And like in this case, that would be if we have the interface person, it implements student or teacher, and then this also implements person implementation. Then it means that the implementation of method work may be one of these two. It can be student or can be from the class teacher. And by directly, you may usually not know from where this logic comes from. But yeah, this is fine, and this is how it can be done for the interfaces. Okay, right now let's maybe have 10 minutes break, and after the break I think we'll finish this presentation. Okay, let's continue. So yeah, here we have virtual methods, which, as I said, basically mean that these are the methods which which cannot have the implementation. In this case, they won't have the implementation when you use the person interface, or they will have just different implementation that they can actually have. Like in this case, if we had any methods in the superclass, then these methods can be overridden in subclasses. Then, in fact, when we use the objects of one of these, and they will, the variable as the personal implementation, and these objects and these classes, one of these classes as the type of the object, then the implementation will be different. Okay, so this is about it, and here we come to interface usage. Basically, the question may be when we need to use the interfaces. As one of the options, these could be that we need to declare methods which need to be implemented in several classes. Because this is actually kind of the same as it can be with the superclasses, but with the superclasses we have one serious restriction that we can only have one superclass. And for the interfaces we can have multiple interfaces. It means that we are not restricted here. We can declare as many interfaces as we want to in the class. So this is the advantage for the interface, but yeah, we can also share them in between the classes. And then we need to expose class behavior without exposing class itself. And this is what I said. No need to declare the superclass, or just we can declare the superclass and implement the interfaces. And then when we need to generalize behavior of different classes without inherited relations. And also this is what I said. And when we need to implement multiple inheritance for implementation of different interfaces. This is also what can be done, and there can be one more thing, and one more thing is that we already gone through, is so-called marked classes. So it means that we can have the interface. The interface may have no implementation. We'll have such examples later a little bit, but the idea is that we have a bunch of classes. Can be some classes there, and each class can be, or some of the classes can be marked with the interface. So it means that we have just the interface without any attributes, just the interface, and that's it with the name. So it means that we can point to some of the classes, that these classes implement the interface, and it means that these classes are marked with this interface, so they can be it can be used in some way. Like we can also, in theory, we had such examples like the box of candies and box of toys. We could just create another markers, like let's say box A and box B, and no, that's not the best example. Maybe we could add some we can imagine some properties. So that can be property 1, property 2, just any property, and then we could split the objects into classes using the properties. So without any members, then without any properties of the class directly. I mean the attributes, the values of the attributes or the class type, but using the marker interfaces. This can also be the usage of the interfaces, just to mark the class. if we do the marker, we do not change the behavior of the class. We don't add any restriction directly to it, but then we can check if the class is marked or not. Yeah, then we have such thing like robustness principle. You can check it in Wikipedia. Maybe I can simply read the definition. Yeah, there's such quote: be conservative in what you do and be liberal in what you accept from others. This is maybe what we can apply to the first one. We can apply, we can describe what the interfaces are. And so this is the quote. We can accept, it means that we can accept everything, but we cannot, it means that we can implement as many interfaces as we want, but we need to be conservative of what we do to others, and that would be also to the classes, and in some case to the interface as well. But yeah, what does it mean when we implement the interface? We can accept wide range of types and class parameters, then they are declared by interface. That's true. You can return more narrow types or values, and then declared by interfaces. That's also true. And you can draw only more concrete exceptions than declared by interfaces. Yeah, that's true. Okay, and yeah, then if we can explain the security of the interfaces, like let's say we have the class. As interfaces are a public class, they provide public access to all its methods. So this would be like the cheese. Then we can have these these holes inside cheese, and we can access to them. Yeah, in some cases that can violate encapsulation principle, because we cannot really encapsulate the the attributes and the methods, not the attributes, but the methods of the interfaces. That's because we can only declare them as public. Yeah, so about, in addition about the usages, as abstract classes, interface cannot be instantiated. That makes sense, because basically interfaces are not really the classes, and this is what comes from the name. And then getting working reference to interface may be tricky, especially when using new frameworks. You have to look, you can check it using Java-doc for all implementing classes. Have to check if there is and check if there is check is there instead of constructor, so-called factory method, which uses constructor internally. For example, that can be get reference. This is what I said before for the yeah, that's for the private. You can use private constructors, and in this case you should have so-called factory methods. Yeah, this is what I said. You have get instance methods. These can be also get reference method. These methods can be also called get reference, and we can call them as factory methods. So it means that using these methods we return the right object. Yeah, maybe we'll have the example about it as well, but you will most likely use it in your final assignment in this course. But the idea is that in this case, as you can see here, we don't actually know in general we don't actually know what type of the object this method will return. This is factory method, so it will construct some object, any object class, one of the objects class. And at this point we may not know what the type is. In this case that can be some parameters passed here, and based on these parameters we can get the right reference. So this is what can be used for the abstract classes and the interfaces. For example, again, as for the abstract classes, we know that we can instantiate them, but we can have the factory method, which will return us the variable, actually the object, and which can be typed as the abstract class or the interface. So what does it mean? We have the factory method, which return us the interface or the abstract class, and then inside the factory method we can, based on some information, we can also, again, as I said, provide the attributes to this factory method, and then based on this information this will return us the object. And in some point we can also say that this is also the fact what from the example we had today. In some way we can also say that this is factory method. So because at this point we don't actually know what type of the object will be returned here. That's why we can call it as factory methods. And so this is maybe tricky because nowadays with all the frameworks we have, usually the abstraction is used in lots of places, and we actually may not really be sure what kind of instance is stored under the variable. And this is what I mentioned before. Since Java 8 we have such things like default method, and in fact default method, actually from my point of view, they destroy the concept of interfaces we have in Java, but that's fine, we can use them. So it means that these are the methods which allow us actually to create the implementation of the methods defined in the interfaces. So what does it mean? It means that we have the methods, and inside the methods we can have some logic there. So that would be like in this case we have the interface, and it has the default void. Then we have the class which implements this interface, and we may have the methods here. Not we may have it, we must have the methods here, and we must implement, like in this case, we must implement the method draw, but we can skip implementing method message because it already has the implementation in the interface draw block. So in this case that practically works as the abstract class without 100% abstraction here, because this method is already implemented here and we can use it. In this case interface work as the abstract class, but again there's still one issue. The issue is that not the issue, but the restriction is that we do not have such possibility to use the attributes, the variables, changeable attributes for the interfaces, only the constants. But from the other point we can define the methods, and in this case we can also, since you know that we can achieve multiple abstraction, And for here we can have the not the issue, but yeah, kind of that can be the issue that let's say we have two interfaces, two different interfaces, and both of them will have the same methods. Like let's say the method name may be message, like in this case MSG. And yeah, let's imagine that these two interfaces, they both have default methods. Let's say default method MSG, and both classes have the implementation for them, default implementation. Then you have another class which will implement both these interfaces, and as a result you'll have that you inherit, you will get the default methods from two different interfaces, and they may have different implementation. So and this will result in the problem, because again the compiler will not understand which method should be used for the class, because again the same methods from two different classes, from two different interfaces. In this point you will need to override the method, like this, that will be the method message MSG. And inside this method you can create your own logic. The most usual way is just to call the logic from both interfaces. That's possible. We'll have such an example next time. And also, as I said, we can have marker interfaces or third interfaces which has no members, but they exist. Some of the examples can be serializable, used for the class is clonable, used to point that the class can be cloned remote, and they're used to provide some essential information to the Java virtual machine. So Java virtual machine may perform some useful operation, like again the cloning. Without the cloning, without the marking that the class is clonable, we cannot really clone the object. But also we can create our own class, own interfaces, and just use them as marker interfaces. That can be done again, as I said, to combine the classes in some groups. In fact, if we build the framework, then you may create some different classes for the frameworks there, and there may be such a situation that you need to actually you cannot really combine these classes in different groups using, let's say, the superclasses or some say some standard interfaces, but interfaces you usually use with the methods and so on. You need to mark them in some way. And in this case, you can create a marker interface and use them to distinguish the classes, to combine them in different groups. Let's have the overall summary of what are the differences between the abstract classes and interfaces. So the first point is for the abstract classes we can have abstract and non-abstract methods. In interfaces we can only have abstract methods, and since Java 8 we can have such default and static methods also. Then abstract classes does not support multiple inheritance. Interfaces can be used to achieve multiple inheritance. Again, it means that we can have multiple interfaces assigned to one class. That's possible. The abstract class can have final, non-final, static and non-static variables. Interface can only have static final variables. No other options, unfortunately, here. Then abstract class can provide the implementation of interface. Interface cannot provide the implementation of abstract class, so it means that you can implement the interface in abstract class if you want, and if there's such necessity, then you can implement. So it means that interfaces can also be used for the abstract classes, but you cannot use the abstract classes for the interfaces. Then the next point is that abstract keyword is used to declare abstract class, interface keyword is used to declare interface. That's pretty much straightforward. Abstract class can extend another Java class and implement multiple Java interfaces, but interface can extend another interface only. So from the extension point of view, interfaces have less possibilities, but again, it's also possible that one interface extend another interface. That is allowed, and I'll talk about it. Then abstract class can be extended using keyword extends. Interface can be implemented using keyword implements. And so please be careful of what keyword do you use. It's really important. And the last thing is that Java abstract class can have class members like private, protected, and so on. So you can use different access modifiers for the methods of abstract class, and all the members of Java interface must be public. They are public by default. You cannot use other access modifiers for them. Then in Java, this is the thing we have not talked about before, we can have nested classes. What does it mean? It is a way of logically grouping classes that are only used in one place. So it means that one class can also be the part of another class without using the abstraction. That increases encapsulation, so you encapsulate the whole class inside another class. That's possible. And nested classes are accessible only from the objects of the current class. So it means that you cannot use one class without another class. That's also the thing about this. And we'll have examples, so you'll see what does it mean. It produces more readable and maintainable code. In some cases, if you is that you encapsulate the whole class inside another class, so you don't you may not need to store it somewhere globally, then to use it from different places. But if you don't need it, you can do it. And then so in case you want to have something reusable inside your code, but don't need to share it with other classes, then you can use nested classes. And there are two types of such nested classes. There can be static nested classes, often used for different utilities, and non-static or inner classes, often used to exchange structured data, and mostly. They represent a special type of relationship that it can access all the members, data members and methods of all their classes, including private. There's also an interesting thing about them. And the nested classes are used to develop more readable and maintainable code because it logically group classes and interfaces in one place only. And we can also use the nested classes for code optimization because it requires less code. And there are 5 types of nested classes. The first one is member inner class. That means that this is the class created within class and outside the method. So we have one class inside another class, but outside the method. Then we can also have such thing like anonymous inner class. So this is the class created for implementing interface or extending class. its name is decided by Java compiler. Yeah, this is a little bit crazy class. I think quite rarely used, but we'll see such example later. Then yeah, there are so-called local inner class. So yeah, these are the classes which are created inside the methods. Well, it's also possible to create the class inside the methods, and yeah, then we can have static nested class. This is the class created. This is the static class created within the class. So it means that you have one class, then inside this class you have another class, and you can achieve one class from another class without creating the instance of it. Because if we talk about nested classes which are not static classes, then it means that we should instantiate the parent class to access its member class, the inner class. So it means that we should have the object, and then only from the object we can access the content of inner classes, non-nested classes there. And then we can also have nested interface. This is basically the interface created within the class, or there can also be the possibility that nested interfaces are located inside another interface. And yeah, this is how it looks in general. On Wednesday we will go through more examples from the all examples about these type of classes. But in general, this may look like you have an author class, and inside this class you may have another class. Yeah, so this is quite interesting construction. Again, we can have some attributes, but in the same way as we have attributes or the methods, we can also have the class inside another class, and then you can do some stuff. And like in this case, that would be you have the method, and inside the method you can actually access this class. You can create the object of this class and do some stuff from here. So in this case, if you are inside the class, you work with different methods here, then you can just use this class in the same way as you use other classes. Okay. So that will be absolutely the same way, and with all the same properties as all the other classes do. If you work from outside the class, then that could be quite, we'll see, but this will be a little bit tricky. That you first need to have the object, and then from the object you need to access the class, and then you can access the methods of this class. We'll see such constructions, but most likely, but definitely next time. And we will go through the practical examples there. So, if you have any questions, then please ask about the inheritance. So what do you have? You have next home task that would be extra O2. So you can complete it until the end of the week, so until Friday. The extra offer, some of you already submitted the solution for extra O2. So, and yeah, in addition, I think I have not mentioned, but you can also implement extra O1 as an additional activity, so you can get extra points for extra O1 activity. Yeah, and then for next week you have extra O4. Okay, that should also be fine. So yeah, in case you have any questions, you can ask. And I think then we can finish for today. and next time we will have more practical examples on abstract classes and interfaces, on the inner classes. So I think that can be it for today, and then meet you all on Wednesday. Bye, and have a nice evening.